Hello, now we are going to discuss web service slicing and how to do intra and inter-operational analysis to test the changes. This work is being published by me with my professor, and it's published on IEEE Transactional Service Computing. So we'll discuss introduction, proposed work, intra and inter-operational analysis, operationalized parameter regression testing, and then experimentational case study on web services. So what's the analogy between object-oriented programming and service-oriented computing? So first thing is that functional unit. What is the functional unit in object-oriented programming? It's API, and API has classes. So classes are the functional unit of object-oriented programming. And web services is a functional unit of cloud services. So that's the difference or analogy between object-oriented programming and service-oriented computing. Then atomic unit-wise, classes contains methods or functions or procedure, different programming language, different names. Then web services contains operations. Method contains variable and operation contains parameter, input parameter, output parameter. The abstraction of this unit could be like interface is being said in object-oriented programming, and in the web services it's said web service descriptive language. Then what is issues with the current era of web services and related to large web services, we targeted three specific problems. First is operational analysis for large web service. Then we targeted program slicing for large web services, regression testing for large web services. So we'll see what are the contribution in this research paper. Like web service slicing is basically a technique which actually captures some subset functionality of large web services with the help of interface slice. What is interface slice? It is basically capturing WSDL slice and subset of a WSDL it captures that provides access to interoperable slice, which is actually subset of a web service. Then which is what is intra-operational analysis? It basically inspect a single operation. When you do analysis for a single operation, it is said to be intra-operational analysis. And what is inter-operational analysis? When you do inspection of relationship between operations and procedure inside a web service. So it is inter-operational analysis, means multiple operations and multiple procedures inside a web service. Then what is associative code test mapping that we discussed? That it means there's association means there's a combination of code that has some test cases being defined for that. So how that association could be maintained. Then operationalized regression testing of web service, how an operation wise testing could be conducted, how parameter wise regression testing could be conducted. And these are the three definitions basic. That intra operational analysis, as what we discussed, it is same as intra procedural analysis, and it this which considers code within a single operation. Then inter operational analysis, it is similar to that inter procedural analysis, which considers affected operation depending upon other operation or procedures. Then subset web service, basically it's a subset service, basically defined as subset of a web service that provides some of the subset functionality of a large web service. So there's a large web service, you'll have only subset functionality could be accessed with the help of subset service. Then what is web service slicing? So slicing means cutting out a program. How do you cut a program in the program slicing? Like you have a four functions or procedures: add, subtract, delete, and modify. So you can have four different uh, uh, slices possible. So like addition, subtraction, multiplication, and division could be there. So you can have two combination of two services web service could be there. Add and subtract could be one, multiplication and division could be another. So this is how you do the web service slicing. And in the it's a type of program slicing that you separate out multiple methods or procedure that extract subset of a service and provide subset of the original web service. So doing generation of a subset service, that technique is, we propose it as web service slicing. This result in a kind of slice that we defined it as web service slice. Then interoperable slice. Interoperable slice is a portion of web service code that can be accessed as a subset service from a remote client. That client needs a subset functionality, so it can access subset of web service code with that. Interface slicing. So interface slicing basically means program slice that actually extract subset of a given interface that captures subset of original interface behavior, and that results in slices, and that slices are referred as interface slice. So subset operations are being selected in the interface slice, and these subset operation, out of 20 operations, you just select 5 operations that you needed, and creation of interface for that 5 operation means you are creating interface slice, and that is this process is termed as interface slicing. So it is basically having that interface slice basically contains subset of operations in the original interface. Then this is an example of banking web service slice. So this version 1 and version 2, bank service version 1, bank service version 2. Light green represent insertion of some part of code. Light red represent deletion of some part of code, whereas light blue represent modification of some part of code, and oval basically represent operations, and rectangle represent procedures. Then if we see here, there's a banking service which is having deposit balance and withdraw as a operations, or that you can say procedures. And this is calling code, web service code, of deposit code, balance code, and withdrawal code. Then thereafter you can create a subset for that. How you can create subset? So you just create a interface for calling out subset WSDL interface you created for deposit and statement. Now you can only able to call deposit code and balance code for telling out how you want to process that interface slice to access the interoperable slice over here. Then it is really nice to identify three different kinds of WSDLs, subset WSDL. One is difference WSDL, which captures changes in the WSDL, means there's from old version to new version, how many changes has been done. So you can compare it. So you can get the difference WSDL. Then unit WSDL, you can first compare web service code between version 1, version 2, and then get the changes, the changed operations you get and with those changed operation you can create unit WSDL. Thereafter you can have reduced WSDL, which will just say that I want to select these 5 or 6 operations, and from these 5 or 6 operations you select them and say them as, and make our interface and say that interface as reduced WSDL. Then these are basically combined together to form a combined WSDL. So these three WSDL could combine together and form a combined WSDL with unique operation, means remove the redundancy. So it's possible. Thereafter, we'll say that interoperational changes, that actually depends on changed operations and procedures. So how to do the interoperational change analysis? You first find out which are the dependent operations or procedure that has been affected through changes. Then in this interoperational analysis, this parameter WSDL, which actually captures flow of code, means how the code is being flowing, how the parameter passings are being done, with the help of WSDL code level analysis. Thereafter, it is having analogy of database attributes with the web service operations. How that database attributes are similar to web service operation parameter. So it's like a dynamic database, you can say. So that's what no SQL means, CAPS theorem means, where you don't have a specific attribute to be stored of a database. Here in the operation you just store random parameter values, final values, and according to it you can retrieve out the data or the logical result of that parameter from input parameter, and you have a logic and business logic, and then you'll get the output parameter. Then what is input query? So in the database, you basically have input queries. So here in this uh, web service, you have input parameter values. So you mentioned the input parameter values that would be equal to the input queries. Then you have the input output result, and here you have the result of operations. So as a output, key attributes of could be identified, so other attributes. So in the database, key attributes can identify attributes of other attributes could be identified. Similarly here, key parameters actually identifies other parameters. It's possible to identify other parameters with the help of key parameters. Then two or more candidate primary could be key could be there in the uh, key attributes. There could be two or more candidate primary could be possible. Similarly here, candidate primary key could be like parameters are there. There could be multiple number of primary candidate parameters could be there. Similarly, to the database system, there are primary key which actually identifies other uh, keys in the other attributes in the whole database, and there are other attributes are said to be non-primary key. And this primary parameter means the parameter which can identify other parameters. So other parameters are non-primary parameters. Then primary parameters of an operations are uniquely identifiable, identify the other parameters. So we want to find out primary parameter. So all these analogy with database and web service operation, we did it to get what are the primary parameters. Then regression testing of web service. So basically what does it says, that an overview says that there's two type of regression testing or testing of web service could be possible. First one is operational testing. Second one is parameterized testing. So that first one basically uses intra-operational analysis, change of analysis, and second one, parameterized one, would actually use inter-operational change analysis. So we'll discuss this flow chart. It says that you first do the intra-operational change analysis in a web service for getting what are the number of operations that underwent changes. And according to that, you just select out the set of changed operations to construct new kind of subset WSDL. And in the inter-operational chain analysis in a web service that has been affected with the changes happened to the other operations through some code flow. So you just generate a call graph with the help of that code flow, and you just check in that call graph what are the operational interdependencies that are being affected. So you first find out what are the operational interdependencies in the call graph that are being affected. That is inter-operational change analysis. And with that change analysis, you select out set of changed operations that are set of operations that are dependent on changed procedures, and you construct a subset WSDL named as parameter WSDL. Then you create associative code test mapping for both the kind of analysis. First one says that you just do the changed operation and old test case mapping. So, and then in the second part, you do the code flow and old test case test step mapping. So, in first way, operationalized regression test suits are being generated, and in the second one, parameterized regression test suits are being generated. So, these are the two kind of test suits that are being generated. So, what does we want to do analysis in the regression testing of web service? We want to do analysis for change-based web service regression testing. How we can do change-based web service regression testing? Basically, this means to do the change analysis first of all, and then based upon that change analysis, we need to detect what are the affected labels or what are the affected portion of a web service that has been changed. So we want to do the analysis like that. So first of all, we'll say insertions are there, deletions are there, modifications are there in a web service. So these are the three kinds of changes or labels that we can create. So the label says that a WSDL could undergo with some insertion in the operations. Number of operations are being inserted, or WSDL code has been inserted with some of the code. So this how the much location and different location would be affected. So insertion could affect WSDL or data type in the XSD, means schema for the input output for that interface is being affected. So how you can capture this with the difference WSDL and reduced WSDL. Then at the web service code level, there is some insertion happened. So how you can capture uh, in- these code flow changes with the help of unit WSDL and parameter WSDL. Then test cases, basically a template that required suitable test data for all these things. Then you have the deletion at WSDL. There's some operations that are being dysfunctional to the client, so that is deletion. In the web service code, there's some operation that has been code has been deleted or some part of code has been deleted. So these changes rarely occur and do not occur usually. Anyhow, the test cases should need to be failed if there's a deletion of operation, or the test case old test cases should need to detect that deletion. So that is the alarm if you have some unwanted deletion happened. So failure of test cases would tell you that there is a deletion. Then modification could be possible at the WSDL schema, means input output are modified. So how it has been captured? It has been captured in difference WSDL or in the reduced WSDL. Thereafter, a modification could be done at the code of web service, and lines. Some of the lines are being affected, which doesn't affect any WSDL. So, in such cases, it has been captured in unit WSDL, parameter WSDL. So, I hope you understood that what is difference WSDL, reduced WSDL, unit WSDL, and parameters WSDL. Then modification is being how it helps in operationalized testing, and how this modification analysis could help out in terms of code flow and parameter testing. So first you have to do code flow and do the parameter testing for generating this kind of WSU. Then we'll see operationalized regression testing of a web service ORTWS in detail. So what it does, it captures four subset WSDL that we were discussing since starting. Means first of all, it takes old web service, it takes new web service. Then basically what developer keep on updating the web service. So from old to new version has been developed, and you already have test suite for the old web service, and you can generate a difference between web service old and web service new, and you'll get web service difference, and you'll get code differencing as well for that whole upgradation. And you basically also select some of the operations in the new web service. So how you can capture WSDL diff actually captures diff in the difference WSDL. Code difference would actually be captured in unit WSDL, and selection of some of the operation could be captured in reduced WSDL. Then these three different WSDL could help you generate the three different regression test suits, and these three would help you generate the all combined together would actually help you generate a combined WSDL, and that will help you do the operationalized regression test suite generation. So this combined WSDL will help you generate the operationalized regression test suite. So this is how, what are the role of our tester. So the tester could do all these things. Thereafter, this is like web service having deposit operation, balance operation, withdraw operation. Then ORTWS test suite design could be there. So there could be three test cases for deposit, then two test cases for balance, three test cases for withdrawal. So basically, these are the way you actually generate a test suite, and these are the ways to write a test suite and in a testing project. So basically, the purpose is to generate operationalized regression test suite, and this explains the associative code test mapping. This whole thing will actually explains you that deposit have three test cases inside a test suite, balance have two test cases inside a test suite, withdraw have three test cases inside a test suite. So this is the way actually associative code test mapping takes place. Then you have inter-operational change analysis that is useful to do parameterized regression testing. How you can do this, we'll see in detail. The purpose of this is to construct parameter WSDL, and that will help you get the parameterized regression test suite. So what happens, there's source code file or executable files of a web service available online. You use these source code or executable to generate some artifact that creates call graph that actually contains how the inter-operational dependencies are there between the various operations to detect the code flow, that how the code flow is there. Then in the web service code, there's pure code. This is not executable. So in this pure code, you just select out what are the operations and what are the methods, and you just separate out all these operations and method and keep it in a different file for doing the change analysis. Then you do the inter-operational change analysis with the help of these inter-procedural dependencies as well as separate file. And you'll get the inter-operational change analysis for the code flow in an operation. So code flow, how the code flow is being affected, you'll get it from there. Then old test suits are there already existing, and from that old test suit you will generate parameterized reduced regression test suit. How? From original WSDL, with the help of this associative code test mapping, you just select subset of the operations that are being affected with the dependencies that has been changed. So you just select out those operations that are being affected with the changes to create a parameterized reduced regression test suite, or parallel you can create parameter WSTL as well. Then this is an example for doing this kind of associative test code mapping. So it says that you design a parameterized regression testing web service test suite, and this is a web service code. Deposit, balance, withdrawal is there, and you just have the WS code, and that code actually have deposit in the as the operation. This is the code flow, an example of code flow, and you basically find out what are the primary parameters of deposit that need to test a particular type of flow in the deposit code. So you have to know about the code before selecting the primary parameter. And this is the test suite or test environment, you can say. So in the test suite, it is having test cases for credit money, test cases for deposit, test cases for use balance operation. So there are three basic operations that have three different multiple different test steps. So each of the test steps means each test cases. This test case has three different test suits, test steps, and this test case have two test steps, and this has one test step, and this whole combined together is said to be test suite. This is test suite. So this is how that associated code for and test mapping is being done. For deposit, there are three different test steps in a test suite, in a test case. Then deposit. So this is how actually things work in test suite designing and doing the web service testing. So for this, all these things are being automated and being coded as automated web service change management, which is a kind of tool that actually do the change analysis for regression testing of web service. What it does, it takes a web service repository and test suite repositories are being taken out, and WSDL and WS codes are being taken out, and test suites are also being taken out. So with all these things, tool is being generated. Tool is, with all these things is been taken as input by the tool AWSCM for doing the regression testing. What it generates, it basically integrates two things. First of all, it integrates intra and interoperational change analysis done at WSTL and WS code level, associative code test mapping between the changed code and test suite is being done. Then subset WSDL is being generated, difference WSDL, reduce WSDL, unit WSDL, common WSDL, combined WSDL, and parameter WSDL are being generated, as well as reduce regression test suites are also being generated. So these are the input and output of AWS CM. So we did experimentation with white box analysis in ORTWS with SAS and Eucalyptus web service. We also did black box analysis for to do ORTWS with 4 5 available web services like Sunset Sunrise web service, Bible web service, currency conversion web service, global weather web service. We just put yes to denote that experiment are being performed, and there are the changes which are being given in GitHub. We made the changes by ourselves. Then changes could not be performed at the code level. So because code is not accessible, so white box testing is very hard to be done. So only black box testing has been done. So this is how we saw that we got the better output. For example, in case of SAS web service, we got we out of 5 operation, only 3 operations were being selected. So so the 2 operations were added, and out of 4 test cases, only 2 test cases are being selected. So it is having 50% of test case reduction. Similarly, for the Amazon Web Service, there are 23 operations are there in Amazon Web Service. So out of that, 3 operations are being selected out, and this actually created 86% reduced regression test suite as well as 86% reduced uh, subset WSGL. So then there is Eucalyptus cluster controller. In this, we generated a difference WSGL, and difference WSGL captured what? Out of 26 operation, only 20 there are only 2 operations that are being added, and 24 operations are old operations. So out of 26 test cases, only 2 test cases are being selected out, and that resulted in the reduction of 92.31% of test case testing effort reduction, you can say. And you can have black box testing and interoperational analysis. So in the currency conversion web service, you have from currency as the primary parameter and to currency as the secondary parameter. In such cases, 3 out of 9 test steps are being selected. That is helping to select 2 out of 4 test cases. So that resulted in 66% of test step reduction and 50% of test cases reduction. Then in the global weather web service, you have country name as the primary parameter and city name as the secondary non-primary parameter, you can say. So that again, few test steps and few test cases are being selected that resulted in reduction. Similarly, if we say Bible book title could be primary parameter and chapter name could be secondary or non-primary parameter, then the again few amount of test steps are being selected and done the regression testing. Then sunset sunrise web service could have latitude and longitude as the primary parameter, and sunset sunrise day time month year as the non-primary parameter. So there are 2 type of parameter input parameter could be there. Out of 8 test steps, 4 test steps are being selected that resulted in 50% of test step reduction. So this is how you can do parameterized regression testing for web service for specifically for uh, when you don't have code available for all these 4 web service. Codes are not available, these are black box for us. So we did black box testing for them. And these are the example that in the global weather you have Jabalpur, Vellore, Delhi, Hyderabad as the city. Out of them, you can select only 2, Jabalpur and Delhi, for the subset regression test suite generation. Then you, in the book service, you can have 5 different uh, Bhagavad Gita chapter to call out and get the response. Out of them, you can select only two if you want. So that is reduce regression test suite generation. And this is the interoperational analysis, we'll say. How we can do the interoperational analysis? This interoperational analysis, basically, there's a book service which actually calls out uh, many operations and methods. How they are calling out? They are calling out like mm, their operations are like procedures. They calls each other in the coding part. So what happens? You have highlighted bold as the operation. So these 9 operations are there, and there are various procedures. All these are remaining ones are procedures, and they are being called with the help of IDs. Means each procedure has some ID. So these in these operations, basically we choose a book number as the primary parameter and remaining as the non-primary parameter, means verse number, chapter number. So these are the non-primary parameter in these four operations. So if there's a change in the one or two, there's a change in the procedure 3 and 4, that actually affect the operation 1 and operation 21. So means the change has been done. So you need to measure out and analyze these changes. So and there's a again change, whatever in the blue part is the affected with the changes. So you can retrieve what are the affected with the changes with that arrows, and this whole thing, a small thing, has been changed out. Similarly here, out of 18 calls are there with Bhagavad Gita operation 1, and you have all Bhagavad Gita operation 21 uh, is being changed. So based upon that, you only get two, these four has been affected. So similarly for the Bible operation, you have 22 and 42 has been affected operations. 22 and 42 is being affected because of 30 and 25 method has been changed. Method with the ID of 25 and 30 has been changed. That has affected 22 and 42 operation. Means these are number 22 operation number, and operation number with 42 has been also affected. So then uh, then you have this kind of analysis. So out of them you can have a code change level analysis, and you'll get the changes at the code level. So you have basically 3 out of 4 operation are being affected. So you select 2 out of 5 test cases. So this has given you reduction of 60%. And again, 3 out of 4 operation in Bible web service has been changed. Out of 2 operations or test cases, out of 2 test cases, you just select 5 test cases, that again given reduction of 60%. So this is how these things could be done, reduce regression testing. Then what are the observations that we have? The observation is that change analysis can be done with the help of WSDL as well as WS code. Both could be separated as well as mixed together. Means anyone could be skipped if it is not required. Then intra-operational analysis we have seen within an operation. Inter-operation means dependencies are there between procedures and operations. So inter-operational change analysis we have seen. It identifies subset of test cases that leads to reduced regression testing cost. Then it, what we can say, it basically captures with the help of all these things are being captured with the help of subset WSTL. which actually helpful for identifying relevant test cases. So subset WSDL help you do the identification of relevant test cases. Then we had executed and analyzed that interoperational slices could be accessed with the help of interface slice that actually reduces number of test cases for regression testing. Then we had seen systematic way to design a test suite which would have associative code and test mapping. So there's a code and there's a test cases. So how the code and test mapping could be done to conduct a systematic regression testing. Then AWSCM has been proven useful for doing the uh, change analysis based testing, and ACM has successfully generated subset WSDLs and reduced regression test suites. Then, as a summary, we had discussed web service slicing, which actually exploits combination of interoperational analysis and the interface slice, interoperable slice as well as interface slice. In the web service slicing, it is helpful to do the maintenance with the help of interoperability of subset services over the networks. On the networks, you can access only subset functionality of a web service. So it's interoperable subset service you can access. The intra-operational and inter-operational analysis gives rise to two new kind of direction for the regression testing. What we discussed as operationalized and parameterized regression testing of web service. Then this all basically enables to execute subset service. What is that subset service? It's a kind of interoperable slice that actually uses some of the subset test cases, which is being created in the reduced regression test suite. Then uh, eight successful case studies are being there for the reduction. So eight successful case studies are like we did for doing efficient regression testing, and that reduces the effort for that. So there's a paper available on IEEE Transactional Service Computing. You can go to my site research slash AWSM for knowing more, and these are the link for the more videos available on that. So other research papers are being published on IEEE Transactional Engineering Management for Service Evolution Analytics that we are going to discuss next. Subset WSDL to access subset service, automated web service, change management as a tool, how to do efficient regression testing of web service. Then in the next class, we'll discuss about cloud service evolution analytics. So I hope that this part has been closed over here. So bye. Thanks all of you. See you in the next class.